Okay, let's go over some topics in Chapter 3. So, let's see here. Start with simple equation. 2 times 3 equals 6. And I don't know if we officially have talked about this, but we've gone through some of these shortcut steps here. One thing we might do is we might write this 2 parentheses 3 equals 6. So the times here is implied. Or we might write it 2 times 3 equals 6 with a little dot. And one reason we do that is because we're going to start venturing more into having equations with variables in them. So if I have x times y equals something, well, that can get confusing with the times sign and if we're using x's and y's. So it might be easier to write x times y. That makes it's easier on the eyes. And we could also write that x and y, that's also the same thing. Or they'll just drop everything out of the way. Just have kind of a gentleman's agreement that when we have variables next to each other, there's a multiplication occurring. So we might have 15 x times y. So I have a constant here times x times y. So that's the same thing as 15 times x times y, like above. And we might get even more complicated. We might go 15 x squared y cubed, so on and so forth. So while we're doing some exponents, let's talk about some exponent operations. So suppose I have something raised to the m power, and I multiply it by something with the same base, or the same lower number here, raised to the n power. What do I get? Well, the way you do this is you take b, and then you can go ahead and you can, up here in the exponent, make m plus n. So why does this work? Well, think of it this way. Suppose you had 2 squared times 2 cubed. Now notice both of these bases are 2. My exponents can be anything, but my bases have to be the same in order to do this operation. So really what you're looking at is 2 times 2, just put parentheses here, that's 2 squared, times 2 times 2 times 2. So what do you got going on here? You got 2 to the 5th, or 2 to the 2 plus 3. Okay, this kind of goes, next idea here goes beyond the scope of the section, but we may as well bring it up since we're here. So suppose I have, so let's call this case 1. Suppose I have this idea, case 2, where I have b to the m quantity raised to the power n. What does this equal? Well, it doesn't equal b to the m plus n, and we can convince ourselves of that if we do this little exercise we were doing here. 2 squared raised to the 3 power. So what does this equal? Well, this equals 2 squared is 4, essentially. raised to the 3 power, which is 4 times 4 times 4, or we could look at it 2 times 2, so that's 4 times 2 times 2 times 2 times 2, or 2 to the 6th. So this, whenever you have a situation like this, this equals b raised to the m times n. Okay, so 2 different ideas. You can always, you'll probably forget this come test time if you don't have your notes, but you can always figure it out for yourself by just resorting to something you know, like something base 2, raise it to a simple power, and multiply it by base 2 raised to a different power, and just work out what you get, and then you can in fact figure it out for some more complicated relationships if you need to. Okay, not happy with these thicknesses here, but let us proceed. Okay, we're going to talk a little now about polynomials. So a polynomial is a combination of one or more algebraic terms, each with a constant coefficient multiplied by one or more variables raised to a non-negative integer. For example, you might have a x cubed plus b x y squared plus cx plus maybe d. So this is a polynomial, and in this situation here, a, b, c, and d are our constants, our constant coefficients. Notice each of these variables is raised to a power, and that power is an integer greater, well, not negative, it can't be negative. This actually, we could consider this as a power raised to 0, x raised to 0 or y raised to 0, which is equal to 1 if we wanted to. But so each of these is then raised to a power like this. So this is what a polynomial is. Okay, now the degree of a polynomial equals the sum of the highest powers. So for example, if we have 3x squared plus 2y plus z, then the highest power here is 2. So this is degree 2. Let's do a couple more of these. Suppose I have 3x cubed plus 2y squared x squared plus z squared. Well, the degree of this, you might think it's 3 because this is in the front, but it's not. It's actually 4. And the reason it's 4 is because this is raised to 2 and this is raised to 2, and we add these together. So the degree here is 4. It's a 4th degree relationship. So although both of these relationships I have here are polynomials, this would not be a polynomial. Say I had 3x cubed plus 2x squared plus x to the minus 1. Why would this not be a polynomial? Because of this, minus 1 here. Another relationship, say we have 3x squared plus 2x plus x to the 1/2. Again, not a polynomial. because 1/2 is not an integer. Okay? So you could have 3x squared plus 2 over y. Again, not a polynomial. And I think we're going to stop the video here.